Have you ever wondered about the fate of Venus, our neighboring planet? It's a question that has piqued the curiosity of many, especially given the enigmatic past of this celestial body. About 4.5 billion years ago, Venus was not the scorching inferno we know today. Instead, it was strikingly similar to our own planet Earth. Yes, you heard it right. Venus, often called Earth's sister planet, once boasted conditions conducive to life. Much like Earth, it was adorned with water oceans, had a complex atmosphere rich in hydrogen, ammonia, methane, nitrogen, and water vapor. The similarities between the two planets are uncanny. Venus and Earth share a similar size, mass, and density, leading some to consider Venus as Earth's twin. But the resemblances don't just stop there. Venus also had an active internal structure consisting of a core, mantle, and crust, much like Earth. The landscape of Venus was once graced with active volcanoes, and the presence of heavy water in its atmosphere points towards a past liquid water ocean. It's hard to imagine, isn't it? A planet currently known for its extreme conditions, once cradling oceans and teeming with the potential for life. But as we know, Venus is now far from being a hospitable place. Its current state is characterized by a hellish landscape, with temperatures soaring up to 900 degrees Fahrenheit, an atmosphere thick with carbon dioxide and clouds of corrosive sulfuric acid. So, what could have possibly triggered the transformation of a once habitable planet into a scorching hellscape? Venus, once akin to Earth, now stands as the hottest planet in our solar system. But how? What cataclysmic events transformed our sister planet into a fiery hellscape? Various theories propose that this catastrophic climate change was triggered by forces both within and outside Venus. One such theory points to the hyperactivity of the Sun. As stars like our Sun age, they become brighter. This increased brightness could have resulted in a dramatic rise in Venus's surface temperature, ultimately setting off a chain reaction that led to a runaway greenhouse effect. Picture this: as Venus's surface heated up, its oceans began to evaporate. This water vapor, a potent greenhouse gas, then accumulated in the atmosphere, trapping more heat and causing even more evaporation. It was a vicious cycle, one that ultimately led to the loss of all Venus's surface water and a significant rise in its surface temperature. However, the Sun is not the sole culprit. Another theory suggests that massive volcanic eruptions on Venus could have also contributed to its current state. These eruptions form what are known as large igneous provinces, or ellipses. These lips release massive amounts of greenhouse gases, including carbon dioxide, which can dramatically alter a planet's climate. On Earth, we've experienced the formation of multiple lips, and they've been linked to some of our planet's most significant mass extinction events. But on Venus, it's believed that multiple LIP formations may have occurred simultaneously, resulting in a catastrophic effect. The excessive amount of greenhouse gases released by these lips could have triggered a runaway greenhouse effect, similar to the one caused by a hyperactive Sun. These theories, while grim, provide valuable insights into the potential consequences of drastic climate change, consequences that Venus, once a potential haven, has already suffered. Today it stands as a stark reminder of the catastrophic impact of a runaway greenhouse effect, a house of horrors where once there might have been a home. But what are the consequences of its transformation? Venus, now a fiery inferno, serves as a stark warning of the power of climate change. Imagine a world where the surface temperature can reach a scorching 900 degrees Fahrenheit, where the atmospheric pressure is akin to being a kilometer deep in Earth's oceans, and where clouds of sulfuric acid veil the landscape. This is the reality of Venus today, a far cry from what it once was. Venus, our sister planet, was not always the hellish world we know now. It's believed to have been much like Earth, possibly even hosting liquid water oceans. However, a series of catastrophic events pushed Venus over the edge into a state of extreme greenhouse effect. This runaway greenhouse effect is the result of an unchecked increase in heat-trapping gases in the atmosphere. In Venus's case, volcanic activity played a key role. Large igneous provinces, or LIPs, released vast amounts of greenhouse gases into the atmosphere, dramatically altering the climate. With no mechanism like plate tectonics to regulate these gas levels, Venus's fate was sealed. External factors also played a part in Venus's transformation. As our Sun aged and brightened, the increased solar radiation caused Venus's once abundant water to evaporate. The water vapor, a potent greenhouse gas itself, further amplified the warming. Eventually, the water molecules in the upper atmosphere were broken down by solar radiation, and the hydrogen was lost to space, leaving behind a dry, inhospitable world. One intriguing aspect of Venus is its slow and retrograde rotation. Unlike most planets which spin on their axis in the same direction as they orbit the Sun, Venus spins in the opposite direction. This slow or reversed rotation likely contributed to the loss of its magnetosphere, a protective shield that could have helped Venus retain its water and atmosphere. Today, Venus stands as a testament to the power of climate change. It's a stark reminder of the delicate balance that makes a planet habitable, and how quickly that balance can be tipped. Venus has evolved from a potential twin of Earth into a stark example of a runaway greenhouse effect. The story of Venus serves as a dire warning of the potential consequences of unchecked climate change and a clear call to action for our own stewardship of Earth. The story of Venus is a tale of transformation, from a potentially habitable planet to a torrid wasteland. Once upon a time, Venus might have resembled Earth, with a temperate climate and a vast ocean of liquid water. However, a cataclysmic shift, possibly triggered by a hyperactive sun or massive volcanic eruptions, led to a runaway greenhouse effect. This resulted in the loss of Venus's water and the buildup of a thick, suffocating atmosphere of carbon dioxide. The planet's current state is a stark contrast to its past. Today, Venus is a hellscape with razor-sharp lava flows, corrosive sulfuric acid clouds, and a surface pressure 92 times that of Earth at sea level. The planet's inhospitable conditions serve as a testament to the tremendous power of climate change. Understanding the transformation of Venus is not just a matter of scientific curiosity, it holds profound implications for our understanding of planetary evolution, the potential fate of other planets, and even the future of our own world. As we continue to explore the mysteries of our solar system, the fate of Venus serves as a stark reminder of the power of climate change and the fragile balance that allows life to flourish.